Brace yourself for nature's fury as we dive into the most destructive weather phenomena that have left entire cities in ruins and stunned the world. Among nature's forces, few are as awe-inspiring and as potentially destructive as weather. The very air we breathe, the winds that caress our skin, can transform in the blink of an eye into powerful forces of nature, capable of reshaping landscapes and leaving devastation in their wake. In this video, we embark on a journey to understand some of the most extreme weather phenomena on Earth. These are not mere storms, but forces of nature that have shaped civilizations and continue to challenge our understanding of the natural world. Join me as we delve into the top 5 most destructive weather phenomena, exploring their origins, their impact on the planet, and the sheer power they wield. Imagine a column of air rotating with such ferocity that it resembles a giant, whirling vortex descending from the heavens. This is the terrifying reality of a tornado, a weather phenomenon born from the volatile clash of warm, moist air colliding with cool, dry air. The United States, with its unique geography and vast plains, acts as a breeding ground for these atmospheric monsters. Here, supercell thunderstorms, fueled by warm air from the Gulf of Mexico and cold air sweeping down from the Rockies, provide the perfect conditions for tornadoes to form. The iconic image of a tornado is its funnel cloud, a swirling column of dust and debris that extends from the storm cloud towards the ground. This funnel, a visible manifestation of the tornado's intense low pressure, acts like a giant vacuum cleaner, sucking up anything in its path. The Enhanced Fujita scale, or EF scale, categorizes tornadoes based on wind speed and potential for damage, ranging from EF0 with winds up to 85 miles per hour to the catastrophic EF5, capable of generating wind speeds exceeding 200 miles per hour. Tornadoes are a force to be reckoned with. One of the most infamous tornado outbreaks in recent history occurred in April 2011, when over 300 tornadoes ripped across the southeastern United States, leaving a trail of destruction and claiming over 300 lives. The town of Joplin, Missouri, was particularly hard hit, with an EF5 tornado carving a mile-wide path through the heart of the community, leveling homes and businesses alike. But the destructive power of tornadoes is not confined to the United States. In 1998, a devastating tornado, estimated to be an F5 on the Fujita scale, tore through the town of Daulatpur Saturia in Bangladesh, killing an estimated 1,300 people and injuring countless others. These events serve as a stark reminder of the awesome power of nature and the importance of early warning systems in mitigating the devastating impact of these atmospheric titans. Hurricanes are sprawling tempests of wind and rain that can span hundreds of miles across, their power unleashed over days, even weeks. These monstrous storms are born over warm ocean waters, fueled by the heat energy released as water vapor condenses. Warm, moist air rises from the ocean surface, creating an area of low pressure below. The Earth's rotation imparts a spin to these storms, causing them to rotate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Hurricanes are categorized using the Saffir-Simpson hurricane wind scale, ranking from Category 1 to Category 5. Hurricane Katrina, a Category 5 storm, devastated the Gulf Coast of the United States in 2005. Typhoon Haiyan struck the Philippines in 2013 with winds up to 196 miles per hour, one of the most powerful tropical cyclones ever recorded. As our climate changes, scientists predict more frequent and intense hurricanes, underscoring the need for preparedness and resilience. Imagine a wall of water, towering dozens of feet high, crashing onto a coastline with unimaginable force. This is the terrifying reality of a tsunami, a series of ocean waves caused by the displacement of a massive volume of water. These events can include underwater earthquakes, volcanic eruptions, or even underwater landslides. The energy released by these events travels through the ocean at incredible speeds, causing the waves to grow in height. The impact of a tsunami on a coastline can be catastrophic. The immense force of the water can level buildings, uproot trees, and carry away entire communities. Tsunamis are often preceded by a noticeable drawback of the ocean, and that people should seek higher ground immediately. One of the most devastating tsunamis in recorded history occurred on December 26, 2004, triggered a series of tsunamis that devastated coastlines across the Indian Ocean. causing widespread destruction and claiming the lives of over 23,000 people, and the devastating power of these ocean-spanning waves. Another significant tsunami event occurred on March 11, 2011. The earthquake triggered a massive tsunami that inundated the country's northeastern coast, causing widespread damage and triggering a nuclear disaster at the Fukushima Daiichi nuclear power plant, showing the importance of early warning systems and disaster preparedness. From the frozen wastelands of the Arctic to the snow-capped peaks of mountain ranges, blizzards are a testament to the raw power of winter's fury. These intense winter storms are characterized by heavy snowfall, strong winds, and dangerously low temperatures. Blizzards develop when a mass of cold air collides with a mass of warm, moist air. The warm air rises rapidly, cooling and condensing to form clouds and precipitation. As the storm system intensifies, it draws in more cold air, fueling the blizzard's fury. The combination of heavy snow, strong winds, and reduced visibility creates treacherous conditions, making travel nearly impossible. Roads become impassable, transportation grinds to a halt, and communities can become isolated for days or even weeks. The dangers posed by blizzards are numerous. Hypothermia, a dangerous drop in body temperature, is a constant threat, as is frostbite, which can cause permanent tissue damage. The heavy snow can also cause roofs to collapse, power lines to snap, and disrupt essential services. One of the most severe blizzards in North American history was the Great Blizzard of 1888, which paralyzed the northeastern United States with heavy snow, hurricane-force winds, and sub-zero temperatures. The storm left cities like New York City and Boston buried under feet of snow, crippling transportation and communication networks. Another historic blizzard, the North American Blizzard of 1993, brought the eastern United States to a standstill, with record snowfall, hurricane-force winds, and dangerously low temperatures. The storm, which stretched from Florida to Maine, caused billions of dollars in damage and claimed the lives of over 300 people. Blizzards serve as a stark reminder of the power of winter's wrath and the importance of being prepared for the challenges of extreme weather. From stocking up on supplies to heeding weather warnings, taking precautions during a blizzard can mean the difference between life and death. While blizzards unleash winter's fury, heat waves are a silent and often underestimated killer. These prolonged periods of excessively hot weather, often accompanied by high humidity, can push the human body to its limits. Heat waves occur when a high-pressure system traps hot air over a region, preventing cooler air from circulating. The sun's rays bake the ground, further increasing temperatures. Urban areas, with their concrete surfaces and lack of vegetation, often experience more severe heat waves due to the urban heat island effect. The human body is designed to function within a narrow temperature range. When temperatures soar, the body struggles to stay cool, leading to heat stress. Heat exhaustion, characterized by fatigue, dizziness, and nausea, is a common ailment during heat waves. If left untreated, heat exhaustion can progress to heat stroke, a life-threatening condition that occurs when the body's temperature regulation system fails. Heat waves can have devastating consequences for human health, particularly for the elderly, infants, and those with pre-existing medical conditions. During the 2003 European heat wave, an estimated 7,000 died from heat-related illnesses. The 2010 Russian heat wave, which brought record-breaking temperatures to Western Russia, caused widespread wildfires, agricultural losses, and an estimated 55,000 deaths. As global temperatures continue to rise, heat waves are becoming more frequent, intense, and longer-lasting. This trend underscores the urgent need to address climate change and to develop strategies to mitigate the impacts of extreme heat. From the fury of tornadoes to the silent killer that is a heat wave, the forces at play in our atmosphere are a constant reminder of the awesome power of nature. These weather phenomena, while potentially destructive, are also an integral part of our planet's climate system. Understanding these weather events, their causes, and their potential impacts is crucial for mitigating risks and ensuring the safety and well-being of communities around the world. As our climate changes, we can expect to see shifts in weather patterns, potentially leading to more frequent and intense extreme weather events. It is our responsibility to study these phenomena, to learn from them, and to work towards a future where we can live in harmony with the forces of nature. Follow for more top 5 videos.